perfect square that works with 72? 36, good. Now some of you might be going, what about 8 and 9? Well, 8 has 4 as a perfect square in it as well, right? So you want to pick the 36. So break this down to 2 times this. Take the square root of 36, so I'll get 6 root 2. This will be a multiple choice question. Good? Number 2 is the same kind of problem as number 1, also multiple choice. Does anybody need to see another one of these done? Now, please believe me, I'm not going to give you like square root of 1,565,283. I'm not going to do that.
Can you use a calculator?
Yes. All right. So 1 and 2 are same kind of problem, just like that, both multiple choice. Still with me? Can I move on? How would I do this kind of problem? How would I do this kind of problem? I think most of you would feel probably pretty comfortable saying that 3 times 5 is 15. And I could get, I could, if I wanted to, go 10 times 20 to get 200. But I might say this. I know 10 is that. All right, let's go even further. Let's break this down. 10 breaks down to 2 times 5. Those are the 2 prime numbers that work, yes? 20 breaks down to 2 times 10. 10 breaks down to 2 times 5. Do you feel comfortable that this is this and this is this? Now there's a reason, there's a method to my madness by doing it this way. I'm looking for perfect squares, which means I'm looking for pairs of numbers. So this and this would give me a perfect square. Do you agree? 2 times 2 gives me 4. 5 times 5 gives me 25, and that's also a perfect square. So if I took that being 4, if I took that out, that means a 2 comes out. Agree? Because if I took the square root of it. And if I took the square root of 5 times 5, which is 25, that means a 5 comes out. What is left under my radical? 2. And then the last thing to do is you want to take care of the outside. So 15 times 2 is 30, I believe. 30 times 5, I believe, is 150. So I get 150 root 2. That's a multiple choice question as well. And again, this will be recorded. I'll have this on Schoology. Yeah?
Could you hold down 15 root 200 and then
Yes.
taking the 10 out?
Absolutely. Nope. That totally would have worked as well. The reason I broke this down is we are eventually going to get to a point where we have 3rd roots, 4th roots, 5th roots, and it becomes really easy if you break it down to the prime components. But if you see it this way as well, I'm not going to take points off you do it one way or the other. Okay? All right, so that's problem number 3. Problem number 4. How do I do that? Yeah.
You divide it by 4, and then whatever the remainder is what the square root is.
Yep. So why do I use 4 as my divider? You're absolutely right, but why is it? Yeah.
Because it repeats every 4.
It repeats every 4. So the 5th becomes the same thing as I. The 6th becomes I squared. The 7th becomes I to the 3rd, so on and so forth. Okay, so I do this. So I go 4 doesn't go to 3. 4 goes into that 9 times, so I get 36. So I get 1. So I get I to the 1st. I to the 1st is the square root of negative 1. You need to know this. That's all you have to know. You have to remember that. That's also a multiple choice question, where the answers basically come out as -I, -1, I, 1. So it's any of the 4 answers that could happen. Does this make sense? May I move on? How do I do this kind of problem? Am I FOILing this problem or am I subtracting this problem? I'm subtracting. So I'm going to go 20 subtract 2 to get 18. Agree? And then I'm going to get this. What is that going to give me? What does it say?
12i.
12i. Why is it 12i?
5 minus negative.
Yeah, this negative becomes positive. So 5i plus 7i is 12i. That's my answer. That, my friends, is also multiple choice. To answer your question, there's 28 questions on the test.
Is it a test or a quiz?
It's a quiz. It's a 4-letter word.
How many points?
76?
Points?
Is that too many?
No.
Do you want more?
No.
Number 6. How would I do this kind of problem? Actually, I'm going to make that a minus there. How do I do this problem? FOIL. I'm multiplying. Treat it the exact same. So I get 14 minus 10i plus 21i. 21i. Minus 15i squared. What is negative 15i squared? Huh?
Plus 15.
Positive 15. Awesome. So the thing you got to catch you here is you have to realize that's 15 times -1. So that's going to give me 14 minus or plus 11i plus 15. Combine 14 and 15 to get 29 plus 11i. So you have to remember you get that. My friends, that's the first page. That's all multiple choice. Cool? Yay? All right. What does the word discriminant mean? Anyone remember that? That goes along with our x is equal to negative b minus the square root of b squared minus 4ac all over 2a. The discriminant is this. It's what's underneath the radical. If b squared minus 4ac is a positive number, you have 2 real solutions. If b squared minus 4ac is equal to 0, you have 1 real solution. And if b squared minus 4ac is a negative answer, you have 2 complex solutions, meaning they're imaginary numbers. Imaginary. Okay, now what the heck does that even mean? What can you tell me about the discriminant on both of those? It's going to be the same answer on both. There's 2 solutions. So is the discriminant a positive number, 0, or a negative number? Okay? So this has to relate to b squared minus 4ac. So both of these would have a positive discriminant. Is that okay so far? What would this have? Or what would this have?
0.
Yeah, that has a discriminant of 0. So you have 1 real solution there. And then the last one, treat it like this. What's the discriminant of both of those? Negative. So I get a negative as my discriminant. Because it doesn't cross the x-axis, that means you have two complex numbers. Complex number, remember, has a real part and an imaginary part to it. Okay? So if you know that, if you know those 6 iterations that could take place, you can do problem number 7 pretty easily. We good? Okay, I gotta try. Can I move on? 8 and 9 are the same type of problem. Let's say I had x squared plus 6x minus or plus 10. So this wouldn't factor, but if I used, if I knew that b squared minus 4ac, my discriminant, yes? I know that this is 36 minus 4 times 1 times 10. So 36 minus 40. So I get a negative discriminant. So what can you tell me if I have a negative discriminant? Two complex solutions. Does it cross the x-axis?
No.
Okay. So the discriminant's negative. Agreed? Two complex solutions. It means it will not cross the x-axis. Okay? And then if it doesn't cross the x-axis, are there x-intercepts to it? Yeah. Okay, so 8 and 9 are both multiple choice. Problem number 8 and problem number 9 have 9 choices in which there are 3 correct answers. Meaning you need to choose all 3 correct answers. Okay? So on this one, we'd be looking for the discriminant's negative. There are 2 complex solutions is another choice, and it won't cross the x-axis. Let's say I work this out, and I'll just make this up. And let's say that b squared minus 4ac is equal to 0. What can you tell me about that scenario? Using that same language. The discriminant is what? The discriminant is 0. How many solutions and what kind? 1 what kind? 1 real. And if there's 1 real solution, that means that this parabola either looks like this, or touches there, or it looks like this. So it looks like it would say the vertex is on the x-axis. It's a bounce. Okay? And then the only other scenario that could take place is x squared, or ax squared plus bx plus c. Let's say b squared minus 4ac equals some positive number. You can tell me the discriminant is positive. If the discriminant is positive, what can you tell me about the solutions? 2 real. What can you tell me about the x-intercepts? Yeah, there are 2 x-intercepts. So that's all the scenarios that could take place on 8 and 9. I will tell you that 8 and 9 will be any 2 combinations of those. Okay? Can I move on? Good? All right. 10, 11, 12 are all a similar type of problem. Where let's say we have square root of 10 plus let's do square root of 200 plus square root of 18 minus square root of 2. So how would I approach this kind of problem? Could I break this down to this? Could I do that? Could I break this one down to this? Could I do that? And then that's not going to break down. Are those all like terms? So I can combine them. What number is sitting out in front of this root 2? 1. So I go 10 plus 3 is 13. 13 minus 1 is 12. 12 root 2 is my answer. So 10 through 12 are very similar to that. How would I do this kind of problem though? How would I do that kind of problem? Yeah. Multiply that and that. So I get root 30 on top. What's root 6 times root 6? 6. It becomes root 36. Root 36 is 6. Root 30 won't break down. That becomes 2, 3, and 5 if you broke it down. It's not any perfect squares. So that's what you have to do for 10 through 12. Can I move on? (13) and 14 are very similar to what we've done already. One difference might be, how would I do 5i squared times 7i? Could I go 5 times 7? I can. What's I to the second times I to the first? I to the third. I to the third is equal to what? Negative I. So I to the third is equal to negative I. So this becomes negative 35I for an answer. You also might see this kind of problem. How can I work that problem? What do I have to multiply top and bottom by? Conjugate. What's the conjugate of 2 plus 5i? 2 minus 5i? You just have to change one sign. So distribute on top, so I'm going to get 14 minus 35i on top. Foil the bottom. If I foil the bottom, the outside and the inside do what? It cancels, so I get 2 times 2, which is 4, minus 25i squared. What's minus 25i squared? 25. And then double check. Is there a number that goes into 14, 35, and 29 other than 1? Not this week, so it won't reduce. So that's my answer. And again, this is all being recorded, so please feel free to watch this tonight, between tonight and tomorrow. Can I move on? 15 through 19 are all similar types of or 16 through 19 are similar types of problems. Kind of. Very similar types of problems. So first problem, I would do this. Then I'd do this. Take the square root. Don't forget the plus or minus. Very good. So that's the first answer. Second problem, we need to start doing this. I'm going to divide each side by negative 3. Those cancel. What do I do next? Square root. Don't forget the what? Plus or minus. So I get x plus 6 equals plus or minus 4i. Why is there an I there? Because I have a negative. And then add 6 to, or subtract 6. Please do not forget the plus or minus. Anytime you take the square root of both sides, make sure you do a plus or minus component. Complete the square is going to be the next ones. Okay? So I'm going to do an example that will be the tougher version. If you could do the tougher version, you could do the two easier versions. Can I move on? So 20 through 22, same kind of problem. This is the tougher version. So let's say we have 3x squared plus 30x plus 15 equals 0. So I'm solving it. I'm not putting it in a vertex form, so I'm trying to solve it. So step 1, we add these steps up here. If these get erased overnight, I'll make sure they're back up on the board. Sound good? Being these have been up for like 2 or 3 weeks now, my confidence level is pretty good that it'll stay there. But now that I said it, I've totally jinxed it. It'll be erased. But I'll put it back up. All right. If I need to make my a value 1, I'm going to do this. Agree? Move the constant, the c value, and make a space. Agree? Next step, make the parentheses quantity squared. Take half of the b squared term and then add it to both sides. This sign has to match here. Put x here, half of 10, 5. 5 squared, 25. If I add 25 here, I add 25 here. Agree? I don't have to plus and minus it because it's not y equals. Okay, so if I FOIL x plus 5 times x plus 5, I get this. Negative 5 plus 25 is 20. What do I do? Yep, root. Don't forget the plus or minus. 2 root 5. Good. Plus or minus 2 root 5. We have to realize that 20 breaks down to 4 times 5, so that's 2 root 5. Subtract the 5. Done. Dude, we're on the back page. (23) and 24 are do the quadratic formula. Does anybody need that? I give you the formula on the test. You want to see it? No? Yeah?
No, that was my question.
Yeah, I have it right up there. It says solve the following equations using the quadratic and has it right there.
Do you have the odds?
I don't, but I probably could squeeze them right there. Will you remind me tomorrow?
Yep.
Okay. Okay, so that's 23 and 24 are the quadratic formula. And I will give you that formula. And then 25 through 28 are just solving. So you might see one like this. You might see one like this. You might see one like this. So 26 and 27 are the same. Then you might see one like this. Those are the last three types of problems. Does anyone need to see those worked out at all? Happy to work them out if you need them. Do you feel comfortable with this quiz tomorrow? You sure? And you said you wanted this. Let's see if this stays up here. Let's see if that stays up there. We good? Happy? We have a couple minutes left. Was there anything from the homework you wanted me to go over? Yeah.
I just have a question. So on like the first problem up there, do you subtract the 9 or do you divide?
This one right here?
Yeah. Oh, that's what you do.
Yeah.
I didn't understand number 7 on 5Q.
7 on Q. The small canoe rental one?
Yeah.
Number 7 on Q. This will not be on the quiz tomorrow. You will see this next week, but it doesn't hurt us to go over it. And I'll just record this at the end. It's no big deal. So number 7, 5Q, number 7. It says a small canoe rental business on a small river in Ohio charges $12 per canoe and averages 36 rentals a day. So it's $12 per boat, and they average 36 rentals a day. Okay. A consultant tells them that if you increase your at 50 cents per rental, the canoe business, you can expect to lose 2 rentals a day. Okay, let me just think. I don't think I put this on the last quiz. Can I hold off on this problem until next week? Let me double check what that last quiz has. I don't think I'll have it on there.
Okay.
This is a great problem because you do create a nice quadratic out of it, but I don't think I'm going to test you on it. I mean, this is a pretty high level. Not that you guys can't handle it. I just don't know if I'll test you. I'll be that jerk of a teacher. I'll throw it on the final exam, and you'll be like, "What? I'm just kidding." So let me double check that for next week. So can we hold off on that thought? Okay. Yeah.
Is there anything about velocity on?
Not on this one. That'll be next week. So my plan, if we go remote, let me stop recording.